I promised I would come in for more. I'm Daniel, and in this video we're going to discuss tuples and maps. Let's get right to it. So in the IDE, let's create a new Scala application. I'm going to name this Tuples and Maps. Make this an object. Okay, and extends app. So tuples are some cute little things. They're basically finite ordered, kind of like lists. Let me show you what I mean. So if I define a tuple, I need to use a new tuple and look at the IDE suggesting options for me. So let's say I have a tuple 2, not a pair, but a tuple 2. And let's put in a value 2 and the value hello Scala. So basically, tuples group things together. I have here a tuple with an int and a string. The type is tuple2 with int and string, also known to Scala as int string, just like that, with parentheses. So this parenthesis is syntactic sugar for tuple2 type parameterized with int and string. If you've worked with Python before, you've probably seen tuples in practice. In Scala, you can create tuples with a keyword new, or without the keyword new, because tuple2 also has appropriate apply methods in their companion objects, or simply write parentheses to comma the string hello Scala. So this is quite consistent with the syntax in other languages. So if you are familiar with Python, this should come as a breeze to you. Tuples can group at most 22 elements of different types. Why 22? That's because they're used in conjunction with function types. And you remember, function x can go from function 0 to function 22. Now, what can you do with a tuple? You can access its members with _1 and _2. _1 is the first element, _2 is the second element. So this will print 2 to the console. I'm not even going to run this. We can create copies. .copy, just as we did with case classes, and we say _2 equals, say, goodbye Java, because I'm evil. All right, so we can have copy methods in the same style as with case classes, and we have a nice swap method, which swaps the elements in place. So this will say hello Scala, sorry, and 2. Let's print these to the console just so we're convinced. All right, so tuples are super easy and also super handy in practice. Let's talk about maps. So maps are collections used to associate things with other things. We say they associate keys to values. Keys are the items by which we index these maps, and the values are the data corresponding to those keys. All right, so let's instantiate an empty map. So I'm going to say a map, which is a map with capital M with 2 type parameters. Let's say we index string and int. So string is the key and int is the value. And the way that we instantiate an empty map is to simply specify map and call the apply method. All right, so much like the list kind of constructing collections, let's create a little more useful map. Let's call a phone book. Phone book, which is a map. And here I can put in tuples or pairings. So say I have the key Jim and his phone number is 555, and the phone number of Daniel is 789. All right. So the way that you populate a map is by specifying tuples or pairings. If you want a clearer syntax for tuples, you can also use this kind of syntactic sugar. Watch what I'm writing. Daniel simple arrow 789. So Daniel arrow 789 with a simple arrow, not with a double arrow, which was used for lambdas. So simple arrow. This guy is a syntactic sugar for the tuple I wrote earlier. So when I say A arrow B, simple arrow B, this is syntactic sugar for the tuple AB. So if I print this phone book, I'm going to see this very nice representation of this map. So map, Jim arrow 555 and Daniel arrow 789. All right, let's talk about basic map operations. So we can query a map if it has a key. So if I say phonebook.contains the key Jim, this thing will return true. So the contains method takes in a key and returns a Boolean. You can also call the apply method on the map. So if I say phonebook.apply or simply call it with parameter Jim, then this will attempt to return the value associated to this key. So if I run this, I'm going to see true because the phone book contains the key Jim and the number 555. But if I try phonebook.apply with a key that does not exist, say Mary, then we're in for a surprise because this will crash. So map.apply with a key that does not exist will throw a no such element exception, which is pretty bad. Now, one option to guard against these potential errors is to add a method called withDefaultValue. So this basically says that when you call apply with a key that does not exist, you'll return, say, -1, which is an invalid phone number. So if I right-click and run this again, I won't get into an error, but I'll get into a -1. So depending on what you need, on what your use case is, you might want to add with default value, or you might want to throw an exception. It's up to you. Now, how do you add a pairing? Well, you need to create a pairing. Say Mary arrow, say 678. All right. And you need to say that a new phone book is the original phone book plus, so this is the add method, plus new pairing. And this will create a new phone book because maps are immutable. So if I print line this, new phone book, I should be seeing the 3 pairings here. So Jim 555, Daniel 789, Mary 678. Okay, now let's talk about functionals on maps. First of all, we have map, flat map, and filter, just like we had with lists. But the way that you would do that would be to say phonebook.map, and the argument here is a pairing, which is a tuple. And for every pairing, say I have pair._1.2 lowercase, arrow pair._2. So I've transformed this map by lowercasing the keys. So if I print this guy out, I'm going to see Jim and Daniel with lower cases, right? So map takes a pairing. So does flat map, so does filter. More useful for maps are filter keys and map values. So filter keys works like this. If I say phonebook.filter keys, and this guy takes a predicate from the key type to Boolean, say in this case that the key starts with the letter J. I'm not going to stress this out, this is a lambda, so X arrow X starts with J. Actually, let me actually use the proper lambda syntax. Too many shorthand notations. So this printLite statement over here will print the mapping where the keys are filtered by this predicate. So the only key that passes this predicate is the key Jim. So the only pairing will be kept for Jim. So if I right click and run this, I'm only going to get the map from Jim to 555 because Daniel does not pass the predicate. Oh my God. All right, we have map values, which is another map specific functional, which is very useful. So if I say phonebook.mapValues and say I get, let's say, a trailing 0 after each phone number. So number, arrow, number times 10, because remember, number is an int. Okay, so this will go through all the values and it will append a 0 to them. So the result is Jim arrow 5550 and Daniel 7890. So the lambda takes the value type, in this case int, and returns something else. So for example, if I wanted to have some kind of 0245 as a prefix, just for the sake of it, so if suddenly all the phone number schemes were changed, if I ran this, I get map from Jim to 0245 555, which is the new phone number, and Daniel the same. All right. So instead of map, flat map, and filter, which are still pretty useful, they apply to pairings. We often use filter keys and map values on maps. Finally, I want to show you some conversions to other collections. So if I printline phonebook.toList, what do you think it'll happen? Well, all the pairings are going to be included in the list. So it will say list of this pairing and this pairing. It's pretty simple. But conversions also happen vice versa. If I say list from Daniel, let's put in the proper tuple here, Daniel 555, and then to map. So notice I've passed in a tuple to a list of a single element, and I convert that to a map. Then I convert a list of pairings to a map. Okay, so the result is map from Daniel to 555. And finally, something very useful is the group by functionality. So let's say I have names, which is a list of, say, Bob, James, Angela, Mary, Daniel, and Jim. Enough names. All right. So if I print line names dot, watch what I'm writing, group by, and I'm passing a lambda for every name, the result is going to be name caret 0. Then this expression right over here is going to group all the names in this list by whoever has the same caret 0 in their name. So this is going to print J with a list of James and Jim because their caret 0 is equal to J. So this key will group this list. A will group the list of Angela because Angela is the only one having caret 0 equals A. And so on and so forth. So whoever obtains the same caret 0 is going to be grouped under the same list. So for example, James and Jim have the same caret 0. All right. Group by is very used in practice, is very used by data scientists, and in particular in Spark applications. Before we get too dizzy into big data, let's recap and do some exercises in the next video. So we've learned about tuples, and you've seen how to construct them, how to access their members, how to copy them, how to do toString, and we've printed them into the console, and we've tested the swap method. We've also discussed maps, which are a super useful data structure to make associations between keys and values. We've seen them in practice, and we've seen a couple of methods, like contains and adding new associations. We've seen some functionals in practice. We looked at filter keys and map values, which are more useful to maps than to other collections. And we've also looked at map, flat map, and filter on pairings. We also saw how to transform maps into other collections and vice versa by looking at toList and toMap and looking at the group by method. Alright, let's take a short break, and in the next video we get some really heavy functional programming exercises. See you there!